Hey guys, welcome to another Factorio tutorial. This one's going to be on including multiple train stops for a given train inside of a factory. So you might find yourself in a situation where you're trying to connect things, and if you're just going to rely on belts, um, you would run belts between everything, and you'd wind up having a bunch of product moving along the ground on a belt. And there's two problems with that. The first problem is that it's not going to move. Probably it'll probably always be a bottleneck because that product is going to take time from when it's produced to when it actually gets to consumer. It's going to take probably a fairly lengthy amount of time. The second thing is if you decide to change your factory and you want to change where the train or change where that product's destination is, you want to move like a part of your factory to another geographic location, you're going to have to pull up a lot of those belts. There's going to be a lot of product on those belts maybe, and that cleanup associated with those belts is going to be extra because you're going to have to find space to put all that product as you're moving your factories. So in a lot of ways, a better way of dealing with producers and consumers in Factorio, especially when the distances are a bit more spread out, is to use trains. And an important part of that is to be able to build trains in a way where they can figure out where to go without having to be told exactly by you. So by the end of this tutorial, we're going to hopefully wind up with a pretty clear example of how to build a generic train system that you can add to, and it's very low cost to change it and make updates and remove old sections of that train system. So let's get started. The first thing I want to point out is this is just a really abstract example of a particular type of scenario. We've got in the middle right here, we've got a producer, an abstract producer. This would actually be like probably your copper plate smelters coming out, some system of belts coming out and dumping all the product into a series of chests where your train gets loaded. I'm not going to include those types of systems in here because I just want to keep it as simple as possible. So along that line, on the outsides, over here and over here, we've got a bunch of containers as well, and these guys are just set to capacity of 1 for now, just for the sake of example, just to keep the train moving, keep the demonstration as light as possible in terms of what it takes to actually keep track of in order to follow the example. So yeah, so we've got this one train and we've got one station. What's going to happen right now is it's a pretty simple train setup. Train's going to fill up over here, drive over to here, drop product off. When it drops product off, I'll wait for 5 seconds of inactivity, and let's just see what happens. So train fills up, drives over there, starts dropping stuff off. It looks like we've already hit our first problem. So the train basically is going to be stuck at this point while this product slowly empties, because it's going to take time to consume all this product. One thing that we can do to get this train moving again, get it back, get it filled up, is to add some circuits to tell the train that it's time to go once the quota has been met for this input. So in order to do that, we'll drop down logic combinator. We will connect all these chests, and this is going to tell us the total amount of product that's been dumped, or that's contained inside those chests. I also like to use lights for debugging, so we'll connect the output to this light. And what we'll do is we'll say once our product has reached, we'll say 600 just for this example. You can set this to whatever you want, greater than or equal to 600. we're going to output a signal to tell the train that it's allowed to leave. And that signal will be green. Green meaning everything's good, and it's important that we click 1 here. And so if we want to debug this, the way that we do it is we say if anything is greater than 0, we're going to enable this light and we're going to use colors. So basically when we output our green signal, it'll turn the light on and it'll also provide that color. So we can see the light is green whenever that the crate becomes full. So in order to get the train to follow this logic, we need to connect our signal to the train station like I just did. This is going to be enabled by default, this checkbox. We don't want to enable the station. We want to send these contents to the train so that we can tell the train, hey, you know, when you've reached your, when you're told to leave, when our circuit condition is greater than 0, then go ahead and head back for fill up, or for head back to get filled up again. And so this is pretty good. So we've managed to streamline the train leaving the station. So it's going to leave as soon as possible, get back to here, maybe start tackling some other jobs. So let's just see this in action. Yeah, so it comes back as soon as these crates get filled up once light turns on. So all that's great. Everything's running well. The only problem is that this train is coming by fairly often. It probably only needs to come by once product is low here. So the second thing I'm going to do is add a condition to turn the station on only when the product is low. This is all, I'm describing it with respect to one consumer and one producer station for one train, but this, what I'm doing will lead to it's the integral part of scaling one train to handle multiple producers and multiple consumers. The reason for that is because this train might have other jobs to do, so it's important that it's not spending all of its time or spending longer than absolutely necessary dealing with this station. So that's the idea behind that. So we'll come into here and we're going to deactivate the station if product ever falls below, we'll say 200. And the way that we're going to deactivate it is we will output a yellow signal if that ever happens. And in order to actually make all this work, we just need to go into the train station and we need to say we're only going to activate this station if the signal is yellow. And one thing we'll be able to notice is if you look really closely right here, you can see the red lights flashing on the station. That lets us know that the station is currently inactive. One other way that we can see that is if we come over to the train station schedule, we can see that station is now red. So the beautiful thing about the way that we did this is in Factorio, trains have, train schedules have an interesting characteristic. When we program this train to go between copper and copper in, we didn't tell it to go to a specific station named copper in. We basically said we wanted to go to any station named copper in that's currently active. If there are multiple stations that are currently active, it will always go to the closest one, which might be something to think about when you're building your own factories. So what I want to do is I want to be able to scale this scale this train network up so that instead of just handling this one consumer, I want to add this as an additional consumer. So my first step is to add some inserters. Next step is to add some track. We'll just drop that in on there. And now here's where the nice thing about this particular setup comes in, is that we can just take the station and our control signals, and we can copy this in a blueprint. We're going to keep the station name, and then what we can do is we can drop this blueprint down right here. Let's just make sure that I copy it. And now immediately we can see our trains coming to here. Now, one important thing is that our cargo was not hooked up to it, so we just need to, or our crates are not hooked up to it, so we need to hook those back up just so we can get this train responding to the proper signals. And there we go. Now what we have is a new consumer that was super easy to add to the same train line. And this train will now be able to do the job of servicing both this consumer and this consumer. And this makes it really easy to just add new little pieces onto your factory wherever they need to go, and keep scaling things up virtually indefinitely. So just as another example, we can copy this whole thing, keep station names. We'll put that over here, and we'll extend this track to go to this point. We'll extend this track to go to this point. And you may have just noticed that when both these two were yellow just now, the train pulled into this one, so it always goes to the closest one. And there we go. So now we've got one train feeding 3 consumers. It's really easy to add these guys wherever you want. If this were a mining patch, for instance, what we could do is only have this station turn on when the mining patch has stored up enough for the train to get a full load. And what's really good about that particular setup is you can have multiple mining patches scattered throughout that are all constantly becoming exhausted, as well as new mining patches coming into being that are, going to start mining for their first time. And all you need to do is just make sure that your train names and your interactions with your train wait until conditions, you just need to make sure that all those are consistent across all of your producers, and they're also all consistent across all of your consumers. And you'll be able to scale things up pretty much indefinitely. So in my factory, I've got a number of these like little outpost stations, and you can see where I've got something like this already at play. So we've got solar powered little outpost for mining, and once again, this guy will only ever come on once there's enough product stored up. And I've got trains that run out to these guys to collect materials, and it always, as the trains are constantly pulling product from these things, it'll always try and pull from the closest ones, and then once those guys are exhausted or they're running a little low, the train will start going out to the farther ones. So thanks for watching. Hopefully this helps you.